Hello, this is Mr. Stansbury. I'm going to take you through the 10 H notes on the sine rule. Alright, so at the end of this you should be able to say that I can use the sine rule to find missing measures of a triangle. Alright, so let's jump into what the sine rule is. So the sine rule says that basically you can take the ratio of an angle and the side across from it, and that should be the same as the ratio of the sine of the angle to the side opposite of that angle. Okay, and the nice part about this whole sine rule here is that this works on non-right triangles. All right, so that's what we're going to start getting into here. All right, so find the length of AC here. So again, you'll notice we have 58, 39, and that adds up to be what, 97. So this is not a right triangle at all, but we can still actually find, by using the sine rule, we can actually find missing sides and missing angles. All right, so to find the length of AC, so this is what we are looking for here, right? This part right here. So let's set up a ratio. So we know that we want to do 58 and this side because that's what we're looking for. So we would say do sine of 58 and versus the side across from it, which we'll call question mark at this point, is going to equal the sine of 39 over its side as well. So equals sine 39 over 12. Okay, and then at this point here, once you have the like two fractions that are equal to each other, we just do cross products. Right? So we're going to do this times this should equal this times this. So question mark sine 39 should equal 12 times sine of 58. All right, so divide both sides by sine 39 and we have our answer. So our missing side is going to be 12 times the sine of 58, all divided by the sine of 39. All right, so let's get our calculator out and see what we can figure out here. So again, just make sure we're in degrees if you're using a graphing calculator. So we'll do 12 sine of 58, and I'm going to make my life easy. I'm just going to do that and push equals, and then I'm going to take that answer and divide it by sine of 39. Sine of 39 equals 16.17 centimeters. So question mark side equals 16.17 centimeters. Okay, so really what they're asking for is just find the length of AC, so let's just do this. So AC is equal to 16.17 centimeters. Good? All right, let's take a look at another example. This is example 21 from page 342. It says find the measure of angle C in triangle ABC if AC is 7 centimeters, AB is 11 centimeters, and angle B measures 25 degrees. Okay, so let's set that up. So here is our triangle. Okay, so here's triangle ABC. It says AC is 7, AB is 11, and angle B is 25 degrees. Okay, so whenever they give you some kind of triangle like this, it's wisest to set your two sides up on the top sides like this here, and then your angle B down here at the bottom if that's the way that it works out, and I will show you why in a minute. Okay, so what we want to do is the same thing we just did, and we want to set this thing up and see if this will see what it works out to be. So let's see, we are looking for measure of angle C, so let's call that our theta there. So sine theta over its opposite side, which is 11 centimeters, should equal sine 25 all over its opposite side, which is 7 centimeters. Cross products, and go. So let's see, we have 11 sine 25 equals 7 sine theta. Divide both sides by 7, and we get that, sine theta is 11 sine 25 divided by 7. So let's get our calculator back out here. And 11 sine 25 gives us 4.64, and now we're going to divide that by 7, right? And we get 0.664. Now since we're looking for an angle, we do second sine of that answer. So we do second sine of our answer, which is second answer, and we hit equals, and we get 41.6 degrees. So theta equals 41.6 degrees, okay, which is angle C. Now, here's the tricky part of this stuff here. This triangle here that we drew looks pretty accurate, and it's good, but the triangle could actually also look like this. This side, this AB is still 11, this AC is still 7, and angle B here, I should have written that in, and that is still 25 degrees. All right? So, but if you'll notice, it looks significantly different, because instead of going this way, the triangle ends up going down in here. But again, these measurements are all still true, so this is what you call the ambiguous case, meaning it could be this triangle or it could be that triangle. We don't know. So what we're going to do is we're going to actually solve both of these. So we're going to look for this angle here. The good news is once we have this one figured out, this becomes really easy to figure out, because if you think about it, this here, if we were to draw the triangle we just drew over there, here, these two angles here have to be exactly the same, because this is an isosceles triangle, so the base angles have to be the same. So since we already figured out that this angle here is 41.6 degrees, to figure out what this angle could be instead of the 41.6 is we just take 180 minus 41.6 degrees, and that will be what this other angle could be instead. So let's figure that out. 180 minus 41.6 degrees gives us 138.4 degrees instead. So theta could equal 100. Oh, I already forgot what it was. That wasn't it. 138.4. 138.4 degrees. So let's do this. So angle C could be 41.6 degrees or 138.4 degrees, either one. All right. That's pretty much all there is for this section here. If you have any questions, please feel free to ask. And again, you should be able to say now that I can use the sine rule to find missing measures of a triangle. And again, note that doesn't say right triangle, just any old triangle. All right, thanks.